this video, we're talking about how to find the gradient vector and maximum directional derivative of a multivariable function. And in this particular problem, we've been given the function f of xy is equal to 2x squared plus 3xy plus 4y squared, and we need to find the gradient vector and maximum directional derivative at the point 1, 1. So we're going to be using these formulas here. This first formula is the formula for the gradient vector. This is the notation that we use for the gradient vector. So in our case, since we're interested in the point 1, 1, we're going to have this gradient of f at 1, 1. And you can see that all we have to do is find the partial derivatives of the function f with respect to x and y, so just our first order partial derivatives. So if we find the first order partial derivatives of f with respect to x and of f with respect to y, here's what we get. So taking the first order partial derivative with respect to x, the derivative of 2x squared is 4x. The derivative of 3xy is just going to be 3y, because 3y acts like a coefficient on this x to the first variable here, so we end up with plus 3y. And the derivative of 4y squared will be 0 because there's no x variable involved in that term. So this is like a constant, and the derivative of any constant is 0. So the first order partial derivative with respect to y, the derivative of 2x squared will be 0 because there's no y variable involved. The derivative of 3xy will be 3x because 3x acts like a coefficient on this first degree y variable. And the derivative of 4y squared will be 8y. So those are our first order partial derivatives. So we could say that the gradient of f at xy is going to be equal to, and we could just plug these in. So 4x plus 3y, comma, 3x plus 8y, like this. But remember, we're interested in the point 1, 1. So then we would say that the gradient of f, plugging in that point, 1, 1, is going to be equal to, and we would just plug in 1 for x and 1 for y coming directly from that point. So we'd end up with 4 times 1 plus 3 times 1, comma, 3 times 1 plus 8 times 1. And we would just plug those in directly. So then we'll say the gradient of f at the point 1, 1 is going to be 4 plus 3 is 7, and then 3 plus 8 is 11, so it's 7, 11. So this vector notation, that represents the gradient vector of the multivariable function at this particular point. So what's the maximum directional derivative? Well, all we have to do is take these two values that we found and plug them into this square root here. So we would say then the square root of the partial derivative of f with respect to x squared. Well, this was our partial derivative, but remember, we're interested in the point 1, 1, and we already found that when we plugged 1, 1 into this 4x plus 3y, we got 7. We did it right here. We had 4x plus 3y. Plugged in the point 1, 1, we got 7. So really, we're just taking these two direction numbers, and we're saying 7 squared, and then partial derivative of f with respect to y we said was 3x plus 8y, but when we plugged in the point 1, 1 right here, we got 11. So we take that 11 direction number and we say plus 11 squared, and this value we find here is going to represent the maximum directional derivative. So when we simplify here, what we get is the square root of 49 plus 121. 49 plus 121 is 160, 170. So we get square root of 170. So square root of 170 is the maximum directional derivative, and it occurs in the direction of the gradient vector, which is the vector 7, 11.